So for number 15, we have find the vertical and horizontal asymptotes of the function. Okay, and to save yourself some work, it helps to realize this is the same function from the previous problem, number 14. So if we go back and look, it ended up being 3x minus 5 over 2x minus 7 once we canceled the common factors. So f of x is 3x minus 5 over 2x minus 7. So the vertical asymptote is going to be determined by the denominator. We can't divide by 0, so if we set the denominator equal to 0 and solve for x, that will be our vertical asymptote. So x is going to equal 7/2. And then the horizontal asymptote is determined by the coefficients of the highest order of the variable. So this is going to be y equals 3/2. And if you think about it as x heads to infinity, the constants don't matter much anymore, so essentially we're heading to 3x over 2x, so y equals 3/2. We'll go check their solutions. So the vertical asymptote is x equals 7/2, and the horizontal asymptote is y equals 3/2. So I'm just going to show you in the calculator we have the actual function that they gave us unfactored, and the numerator, in the numerator and denominator we had 2x plus 1. So if we set that equal to 0, that's where we'll have a hole in the function. So that'd be at -1/2. So I'm going to go menu, trace, graph trace, -0.5, and we see that it's undefined. So there's actually a hole at x equals -1/2, and we could do our alternate function, which is this, to find out what the y value is. So negative menu 5, 1, -0.5. Go down here, so -0.5 and whatever that is. And then we know that the horizontal asymptote is 3/2, so I'll put in 3/2. So there's our horizontal asymptote, and I'm going to go to a relation, and I want it to be, say, pink. So I'll say x equals a fraction 7/2 halves. So there's my vertical asymptote. And that concludes this video.